Hello, my name's Pat Ryan. I'm the CEO of Ucore Rare Metals. Here today to talk about turning geopolitical uncertainty into opportunity. A lot of geopolitical tensions that are in the air today. We've heard about tariff wars that are percolating with Mexico and Canada, and there's a 10% tariff that's been piled onto China, and China's finding ways to strike back now. And as you look at this first chart on the screen in front of you, it shows the dominance in the critical mineral space that China has. Of the 50 or so critical minerals that are designated as such, half of those are actually controlled by China. And so there are a lot of different tools in the toolbox, a lot of different ways that China can strike back and very effectively. On the extraction side, you can see here on this particular chart that there's a control in various industries, some of the battery materials, cobalt and whatnot, where extraction is maybe not in China, but the processing is in China. Rare earth elements, where a lot of the extraction is actually controlled in China, but then the processing side itself, processing and refining, China has quite a grip. And although you may not control the extraction in a certain area, you can actually control the market by controlling the processing and refining. So it's a very difficult situation that needs to be overcome for the Western world. The U.S. in particular, as they look at mounting tariff wars, they better move quickly to find a way to refine and process in order to take on this definite advantage that China has, both in extracting, but in particular in processing. So you can see in this picture here, just a bit of a fade on the right. That's the actual commercial demonstration plant. Some of you have seen videos about this particular facility, about the size of 2 tennis courts, which is pretty substantial. And it's designed that way because we want to make sure that we're replicating as close to commercial production as we can. So when we gather up and make our flow sheets, our mass balances, our engineering studies that go along with everything that needs to be done to put a full-scale plant in play, we got everything we need to do. The quote at the top of this particular slide you're looking at was actually from an independent evaluator that came in from Australia to take a close look at what we were doing. And his conclusion, one of them, was that RapidSX is an extremely compelling choice for industries seeking to optimize performance and achieve higher recovery rates with improved ESG and safety outcomes. Very impressed by the facility, as many people are. We had 26 visits in 2024, and they were people from government, feedstocks, downstream potential partners, and all of them quite impressed by what they see. The system, as it may not have been clearly identified on some of our information, is actually a pressurized system. So it's not open to the environment much the way mixer settlers are. It's very pressurized. And in doing so, the first thing you notice when you walk into the facility, there are actually no vapors in the air. Typically in a solvent extraction plant, you have a lot of vapors. You actually have a lot of potential safety hazards when it comes to flammability. And that does not exist in the RapidSX demo plant in Kingston, Ontario. We can reconfigure process stages. You go from scrubbing to from extract to scrubbing to stripping. You can actually take these modular columns that you see here. They can be reconfigured, and you can do so with different feed concentrates. You can rearrange the order that you want to have things done in. You can do so with production stages. Makes it very effective. And finally, that modular scalable nature of RapidSX, it greatly enhances the space utilization. So whatever your space might be, in our case, we're building our first plant in Alexandria, Louisiana. We have the ability to reconfigure the plant accordingly with these columns and contactors and phase separators, and very, very different than a mixer settler plant. So again, solving this Western world separation problem, refining problem, RapidSX is right in the wheelhouse. So the importance of some of those process flexibility advantages that I just described are really that you've got to have that as you address emergent industry needs. Rare earths are a series of 17 elements, and 4 of them are the critical ones that are used in magnets, but there are many others as well that fit into different industries. You've got to be able to target those effectively with your flexible manufacturing. So when you incorporate 21st century techniques like digital manufacturing, flexible work cells, you develop a very unique way to take on that 40-year advantage that China has been able to put together. As many of you know, we have a DoD funding program. It's known as an OTA, or other transaction agreement. And really what that agreement is, it's an agreement to run many hours with our process, with our tech, as the U.S. looks to find a way, U.S. DoD looks to find a way to optimize this tech for commercialization. So the real opportunity here is that the DoD is looking at a diversified processing approach. We know what China is doing, solvent extraction. How do we do that better in North America, in the Western world, in the US in particular. That's the first one. And the second one is that they want to address the defense industrial base. So those are all the needs that go into the defense mechanisms that the US needs to make sure it's secure, but also into the critical manufacturing base. So they're looking for a diversified approach to the technology, such that you're not just dealing with defense needs, but you're looking at the emerging industries. And though some of those emerging industries are noted at the bottom of this particular slide, things like artificial intelligence, robotics, semiconductor, supercomputing, green energy, autonomous driving, sustainable energy, sustainable tech. All of those are really, when you invest in Ucore and you invest in this processing and refining, you're really investing in all those industries, because the processing that we're able to achieve with our rare earth separation and fine tuning allows you to pick out specific rare earth elements, oxides that can be used in these particular industries. So it's a very unique way to approach all those industries. And again, any investment in Ucore is investment in those industries. If you consider one of these emerging industries, the use of AI with robotics is a large rare earth demand. Consider artificial intelligence as being the brains of a robot, and the robot itself is the one that actually is the body, and it carries out the function. A robot can work by itself and just perform a task over and over and over, but when you incorporate artificial intelligence with it, it becomes a very valuable tool. By 2030, $800 billion, that's the projected AI growth. And we hear a lot of this in the stock market talk these days. Robotics by 2035 to be the largest user of rare earth permanent magnets. And a lot of those applications are things like automation in production. You see automotive plants where everything inside the plant is really hands off with a human side, but very much robotic and automation that makes it happen. Food processing, same thing. Hospitality, this humanoid robot that you see here is an up-and-coming feature of the hospitality industry. Global logistics, e-commerce, the Amazon warehouses, you've often seen shots of things going on inside an Amazon warehouse. All that's made available with rare earth elements. So Ucore is pursuing key stakeholders in those markets, and it's a very big area of growth. And again, you've got to have the ability to process and get specific with your rare earth elements, or oxides in this case, to be able to develop a finished product that's very usable in that market. Another emerging industry that's very much dependent on rare earth elements, semiconductor manufacturing. You won't make a good semiconductor unless you have rare earth elements. The preciseness of producing a semiconductor chip, and there are many different forms of chips that are used in various electronics and smartphones and different applications. And you won't make that semiconductor chip unless you have rare earth elements that allow that to happen in a very precise way. And the geopolitical tension here is quite elevated. Taiwan stands in the way because, they're at the epicenter. They control 50% of the manufacturing of semiconductor chips. And China views them as being a breakaway province that they'd like to reunify with China. The U.S., of course, has threatened that if you attack Taiwan or do anything to bring Taiwan back into the fold, we will be there to defend Taiwan. And it's really based on this semiconductor market that is very much controlled by Taiwan. Taiwan Semiconductor Manufacturing Company is, again, the largest semiconductor manufacturing company in the world, and it pretty much controls everything. Remember at the start of the pandemic when automobiles could be delivered after a certain amount of time, but it didn't have a computer chip or several computer chips. You had to wait for that chip in order for the vehicle to be made usable for you. So a very charged area that needs to be looked at very closely. By 2030, a $1 trillion industry. So again, the risk here, the need for supply diversification, lots of investments have been made in the U.S. market and Japan to try to break away and create it, but it's all dependent on rare earth, and Ucore and its ability to refine and develop specific rare earths that go into this market are very much what is needed. So full circle back to, Ucore's modular and scalable process, optimized performance, nimble and efficient, boutique and bespoke type manufacturing opportunities in Louisiana because of the way the process is designed. It can be turned on and off and target specific reads. Everyone wants to go after the magnet reads for emerging markets, heavies and lights that go into those, the neodymium and praseodymium. along with the heavies. But there are other target rees that very specifically have opportunities. The outliers like gadolinium used in nuclear reactors with nuclear rods, lanthanum and cerium used in wastewater treatment, also used in energy storage systems, very important in energy storage, or samarium used in samarium cobalt magnets. Samarium is very much a high temperature, low temperature performing and very not susceptible to corrosion. So it makes it perfect for defense type applications. So again, the ability to target specific rees, not just the magnet rees, look at the emerging industries and really go after those particular customers, and be able to address in a production fashion that's very much in line with a growing Western world market. Grow with the market, grow with feedstock sources that are multiple in nature and can be brought into your process effectively, and creates a heck of an opportunity for Ucore and something that's needed to break the grip that China has and reduce geopolitical tensions.